Can it see you?
Hold on, I'll look.
You think she needs to be closer?
Yeah, I see me. It can go closer,
Like somewhere else?
but I don't know how you do that. I know a big squat nothing about Max.
Say
Who's
hi.
Yeah. Hello. Well, here, what happens if we just
Move it.
Yeah. Here, what about this? No. If we put it here. I love that we're recording all of this. That seems better, although it seems kind of angled. Okay. Okay, so here we go. So we've got 2x minus y equals 3. And 6x minus 3y equals 9. Okay? And I say solve the system of linear equations. Right? What?
The bottom one is just like the top one multiplied by 2. Yeah.
Quiet, Sam.
They're the same equation.
Quiet, Jack. I mean, actually, that's great. Okay, so Caitlin, just so you know, what they're saying is they're recognizing their similarities. What we see here is this times 3. This is this times 3. This is this times 3. But we're going to pretend like we're still sleeping and we didn't notice that. And we're going to solve it the old-fashioned way. Okay? So how do you want to solve it? Doesn't matter. I don't care which way it makes you all happy. Is it bad if the screen goes like...
No, it's fine. As
Okay.
long as there's like a green dot.
There is a
above
green
the
dot.
camera, then it's recording.
Okay, that's good. We're recording for Caitlin this morning. Who's not going to be here.
Hi, Caitlin.
Yeah.
Okay,
so how do we want to solve this?
Yeah, we could FaceTime her. She's not.
Yeah, well, I'm not here. Yeah.
Taylor's a good.
Okay, so the boys say they want to solve this by elimination. Hi.
Ooh, I can do it. Do you have a key in the building? Mine does not open the doors,
Which doors?
like the storage door.
Oh.
Yours, yeah. Okay.
That's bad.
Wait until the office opens, perhaps. And get...
Yes, we're going to have to, because, yeah, I'm pretty sure I gave mine back at the end of the year.
Okay. This
So,
one's like a half key. It only.
yeah, that's the one I used to have.
Yeah.
Yeah, it stinks.
All right.
I'm sorry.
Thank you. Bye.
Bye.
Continue with change it. Oh, nothing.
Did you guys know she was a math teacher?
No, but I knew she was good at math.
Yeah, she was a middle school math teacher.
Yeah, she said although she could teach up to algebra.
Yeah, she could. Yeah, so I guess I technically make her high school too. Yes. So she just hides it behind all that Spanish. Okay,
Divide the bottom by 3.
divide the bottom by 3.
Multiply the top by.
Thank you, Jack. Yes, if we're gonna do elimination, we don't divide things by, we multiply things by a factor, Sam. I understand. You're not listening to me when I say pretend you don't know that, and let's solve this normally. You can do it, buddy. Thank you, Jack, for giving him that little patronizing pat. Okay, so we're going to multiply the top by -3, right? So multiply everything by -3. -3. Good morning.
Hi,
-3. Okay, so then I'm going to put my answer down here underneath. So I got -6x. Oh, look at that. I've got +3y. Look at that. And I've got -9. Okay, now we're going to add them together, and what happens when we add them together? Shock of all shocks. 6x minus 6x is 0. -3y plus 3y is 0. 9 plus -9 is 0. You notice the trend, right? So in the end, what I end up with this answer is 0 equals 0. Okay? And so this tells me something. When I come up with this, well, first I want to make sure I didn't do bad math to get myself here. But if I get myself here, ding, 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 ding. This tells me something. Yes?
Are they the same one?
Are they the same line, Sam?
Yes,
They are the same line. You know how I can know these are the same line?
Put it in the slope.
Well, right. I could switch these, right? If I have 2x x minus y equals 3. And I want to put this in slope-intercept form. I would, subtract 2x from both sides, which I shouldn't really do it that way. So I'd have negative y equals negative 2x plus 3. And then I just switch signs to make these positive, and that'd be negative. So my slope for this one is?
2.
Right, okay, so here's the slope of this one. And then I have what? 6x minus 3y equals 9. I'm going to subtract 6x from both sides. This is how I should have done it. Negative 6x plus 9. So those guys all go away. I've got negative 3y equals negative 6x. I'm going to divide everything by negative 3. And, ooh, shock of all shocks. Look at this. Negative 6 by negative, that's positive 2x minus 3. They are the same line, right?
Well,
And
they
so,
have the same-
but I didn't need to do all this math. That's lovely, and that's another way that we know these are the same line. What, Sam?
But they could have the same slope, they might be the same.
You're right, they could, but they are the same line. How do I know they're the same line?
B.
Yes, the y-intercepts are the same. They're both negative 3, so these are the same line. We were all right back in the beginning. This is just a multiple of this. I've multiplied all of this by a factor of 3 to get this. Okay? So this is great, and we did this math, and we know that these are the same line, but I didn't need to do all of this math. When I get an equation to work out, so it says 0 equals 0, then I know 0 equals 0 means they're the same line. Okay? And now, there's a happy little way, before we would have just said they're the same line. But now, you know, because we're older and wiser and we like to sound more mathy, there's a different way of writing this, okay? And the way we're going to write the answer in this whole set builder notation that we've used this year is we make happy little braces, okay? And in parentheses we put x comma y, okay? We don't plug in numbers here. We literally put x comma y, okay? And then a little dividing line. And then we write down the equation that is kind of in the base form, right? So we talked about one of these is a multiple of the other, right? So this 2x minus y equals 3 is kind of our base equation. This is just a multiple of this. And so I'm going to write down that base equation, 2x minus y equals 3, okay? And then happy little braces. And so the way I read this is my answer is every x and y that relates or is an answer to 2x minus y equals 3. And so what that means is my answer can be any x and y as long as it works in this equation 2x minus y equals 3. So I can't make x and y anything I want to. They've got to work so that if I plug them into this equation, it's true. Does that make sense? I can't go, this is 4 and 2, and that math doesn't work. But if it's, whatever, I could be, 2 and 1, okay? So, this is how I would write the answer. It is the same line, but this is what I'm going to be looking for as an answer. Okay? So just remember this little happy form. Got it. Then, okay. There you go. Don't mess this all up for me again. I just know it. I just sense it. Y equals 4, negative 2, minus 6y equals 3. Okay. How do we want to solve this? Substitution, elimination. Ladies, you pick this time. The boys pick last time. What makes you happy? Substitution, I think so too. Flip this around. So, here, let's rewrite it. We'll do it over to the side. So x plus 3y equals 4. I assume you want to solve for x. Yeah. Okay, so x plus 3y minus 3y equals 4 minus 3y. So x is 4 minus 3y. So now I'm going to take this, right, and substitute it in up here. So every time I see x, which is right there at the start, so negative 2, 4 minus 3y minus 6y equals 3. Okay, I need to distribute this out. So negative 8 plus 6y minus 6y equals 3. Okay? All right, obviously I can add these guys together. But when I do that, they cancel. So I got negative 8 equals 3. This is goofy and doesn't seem to make a whole lot of sense, right? Yeah, but I'm going to move this to the other side. I'm going to move the 8 to the other side. So I'm going to add 8 to both sides. So 0 equals 11. Okay? I probably could have left it like this. But in the book, they kind of work this all the way out to where they get 0 on one side and another number on the other. What?
But wouldn't what you call it be easier? Elimination?
Well, does it matter? I've got an answer.
Yeah, but
It doesn't matter how you do it, right? And there's going to be, like, if you had a problem like this on the test, you never know, wink, wink, nod. I don't care how you solve it. I just care that you get to this, right? Now, does 0 equal 11? No, right? This is obviously not true. So I want to make sure my math is all good, right? But if this is what I come to, this is a sign, okay? This tells me that now, Sam, right? If I went, and let's just do it because we can't, and we've got, ooh, no, we don't have time. If I sat and I converted these into slope-intercept form, what you would find is that their slope is the same, but their y-intercept is different. So that means these are parallel lines. Okay? So if I get 0 equals some number that's not 0, then I know these are parallel lines. Okay? And remember, with all of these systems that we're solving, what am I trying to find? What is that answer when we get to the end, whenever we're solving all these? What are those answers?
the intersection.
Right, they tell me where they intersect. Are parallel lines going to intersect? No. Right, so my answer, this is a lot easier than the last one, my answer is 0, nothing, zilch, nada. Right? Because there's not going to be any point where they intersect. They're just going to run alongside each other forever and ever and ever. Okay? So we hadn't really talked through that here in class. I want to make sure, especially for the same lines, that you're writing those solutions and that set builder notation. Okay, we need to go downstairs here in a sec, but real quick, do you guys have any other questions? Anything else we need to work through? Story problems that would be helpful to discuss? No, none of the matrix stuff on the test. It would. Yeah, no, none of that. So none of that on the test. So it's just going to be solving systems with an x and a y. You need to be able to do it by graphing, by substitution, by elimination. Solving systems with 3 variables, the crazy long method. And then story problems. Okay, go downstairs. And then contemplate if you've got anything else that you want to go over, because otherwise we're going to move on to chapter 6.